My name is Travis Dow, and today I will be presenting our paper on behalf of the authors. In this work, we focus on the approximately 30% of autistic individuals who cannot communicate reliably using speech. Some non-speaking autistic people have received specialized training that has allowed them to communicate by pointing to letters on a letterboard. Learning to communicate in this way is a lengthy process that requires motor skills training with a communication and regulation partner, or CRP. In addition to training, the CRP is responsible for monitoring the speller's attention to keep them focused at the task at hand and providing positive, encouraging feedback. Many non-speakers have used this method as an intermediary to learn independent communication using devices like keyboards or tablets. However, achieving this level of independence requires consistent practice by a trained professional. This can pose a limiting factor for a speller's ability to improve. In this work, we describe our method for embodying a virtual CRP agent, named Vic, using an empirically derived behavior algorithm. This prototype is designed to replicate the behavior of a real human CRP and assist the speller in learning to use a letterboard. First, we created an augmented reality letterboard application with a 5-phase training procedure to help acclimatize experienced physical letterboard users with the new virtual interface. We recruited 13 participants for this process and recorded the training sessions using the AR head-mounted devices. Then, we used the qualitative video data to conduct thematic analysis to identify and cluster the CRP's interventions during the training sessions. Following this, we returned to the video and performed thematic analysis on the preceding and following 5 seconds of each intervention to determine what the antecedent and consequent events were. Using this methodology, we coded 404 interactions and we categorized them into 3 emergent themes. These themes were encouragement, prompts, and positive reinforcement. We set aside 20% of the data for validation using stratified sampling. Next, we calculated the conditional probability of the CRP conducting a specific behavioral intervention based on the speller's antecedent behavior. We used these values to create a probability matrix which codifies the probabilistic behavior of the CRP given the speller's behavior. We use these antecedent behavior sequences to define a Markov decision process where each is equivalent to a state-action pair. To bring the virtual CRP to life, we created a 3D character model using Character Creator 4 and animated it using iClone 8 and the Unity game engine. We created a custom behavior tree data structure to control the agent's behavior during runtime using the probability matrix we derived. To validate our result, we conducted a Monte Carlo simulation using the empirically derived behavior model and found that it was significantly better than chance with a p-value less than 0.01. Our hope is that we can use this prototype virtual CRP agent as a baseline to create a more complex agent that can assist non-speaking autistic students improve their letterboarding skills. In the future, we plan to iterate on this design and leverage the Markov decision process baseline to create an artificial intelligence-powered agent that can use reinforcement learning to customize itself to a specific speller's needs as they interact together. Additionally, we hope to conduct a full-scale user study with this improved agent to gauge its effectiveness.